Hey guys, and welcome to Caffeinated Hax. Today we're going to be looking at the Kioptrix Level 2 box, and I've already gone and picked up the IP for it. It's already set up, so we can dive right in. But a little bit about the Kioptrix family. They go from level 1 through 5, level 1 being the easiest, level 5 being the hardest. This is level 2 of 5, so relatively easy. Last video we did level 1. So this one we're just going to continue on. So first thing we're going to do is we are going to do our basic Nmap scan. So this is going to include all default scripts in the Nmap scripting engine. We're going to try and enumerate those services, get their versions and things like that. I'm going to try and get the operating system. I need sudo to do that. I'm going to run Nmap against the target host, which is my local subnet 152. Whoops. There we go. Helps to spell your password correctly. This will take a while. These scripts take a while, the versioning, the operating system enumeration, things like that. So while that's running, we're going to do a quick scan. And if you want to learn more about Nmap, I have that video in the basic tools section of my YouTube channel. Go take a look at that if you want to learn more about Nmap, and you'll understand why this is working the way it is and why this one's longer. This one will pretty much just check out some of the ports that are there, but it's not going to do any sort of special enumeration or anything. It's just going to do a quick scan. And you can see it is in fact quite quick. So right out the gate, what we can see is we see that we've got an SSH port, we've got 80 and 443, so there's a web server on there. 111 might come in handy, maybe as RPC bind. What's this? 616. That's interesting. I don't know what that is. 631 and 3306 is classic MySQL. So I'm sure these will get more and more. We'll get more information when we do our big enumeration scan here with kind of all the guns. But this one can direct us right away, and because port 80 is running, why don't we just go take a look? Open up the browser and hit it. And the first thing we see is the username and password form. So admin, nope. Admin, blank password. Admin, password. Nope. This helps to. Nope. Okay. You'd be surprised how many times those 3 attempts will get in. Because they didn't, you can set up a script and try and brute force if you want, but I'm not going to. What I'm going to try instead is, this looks like a custom-made form. So it's a PHP file. So I'm interested in, actually before I do all that, I'm going to log this, because in here I have my template, right? So there's 3 levels to my templates that I use. My discovery section, and this is all going to be me hitting the box from the outside, right? So I'm going to do my initial network recon. Sometimes I'll do a summary, and then these are all the actions that I took to enumerate the box from the outside. Here I'll have any discoveries, including any information, any credentials I find, any users, maybe without credentials, any passwords that may not have a user associated. You might just find them randomly, and then any versions that I find pertinent. Here, once I get a shell on a box, usually you don't get root out the gate, so that means you have to elevate your privileges, and that means that you're going to have to run some extra commands on the box. That's where these happen. It's very nice to separate these two out, the actions what you do outside the box and the actions that you do inside the box, just because when you go back and you're trying to look at all this, you can easily separate these into these 2 big sections. Right now we're still outside. I've done my Nmap. And I found some stuff, and we'll chuck the actual big script in here when it's done. And we found that. It's nice to keep some notes because it makes your attack repeatable, so you don't have to go back and learn absolutely everything over again on every single box. So in this case, we just found an index.php, and it's got a username and password. We tried some basic stuff, it didn't work. Because this is a custom, or it looks like a custom form, let's try a basic SQL injection bypass. This is a very common bypass, and what you can see is it's a single quote, space or, single quote A, single quote equals single quote A. Why that becomes important is because if they are writing a system where they're just taking these parameters and injecting them into an SQL query to construct their query, this will end the, that single quote at the very front will end the current query, and so this will get interpreted as actual SQL. And remember, because we ended that one, there's going to be another one at the end. And so you can consider this to be an always true evaluation, right? Because A is always going to equal A. So if SQL is, if this is just chucked in an SQL query to build it, what this is going to look like is if username equals some blank string or A equals A, which is always true. So this evaluation will always result in a true evaluation, and so I just copy and pasted it into the password. And we got him. So that login form was vulnerable to an SQL injection, very basic authentication bypass. So and what I'm saying here is, was there SQL injection? Yes, there was. Here is the SQL injection that I did, and it was a success. Sometimes you won't get a success out the gate. What you will want to do is still log. Like if you've tried a whole bunch of things, it's still worth trying, because and putting them down here, like copying pasting the attempts, because if in a bypass sometimes you'll do your single quote. There's a single quote test, which is just putting that in there, and if it results in an error, you know that there could be some sort of SQL injection, but you just don't know what it is. And this list could get very long, and you need to know what worked and what didn't work, or else you just start getting in circles, because you will retry the same thing over again and you can't remember what you tried. So copy and paste everything you try, even if it doesn't work, and then just mark the things that do work as success, and then you can kind of go through quickly and be like, oh, okay, this is the thing that I did. Saves you a lot of time when you're looking back. And we're still on index.php, but a different page. Some sort of basic administrative web console, and you can ping a machine. Alright, well, that's my Kali box's IP. So what happens if I run it? It looks like it actually runs the ping command, like just straight up runs it against this IP. So this is probably another really good possibility for remote command injection. You can see that this is going to look very similar to like and I have to kill it with Control-C, but you can see these look very similar. This is the target host, and then this was just me pinging my Kali box. In fact, they look pretty much the same, so you can pretty much guess that I'm pretty sure there's got to be a, like, it's probably just taking this input and then just dumping it, much like the username and password, into some sort of command line, well, into the ping tool. So let's try it out, and we're just gonna end the current command and then execute the ls command and see if that works. And it does. Okay. So what happened here is if we go back to our ping, if I do a semicolon ls, and I have to kill the I have to give this like I'll just one ping. Okay, so that's just a flag that tells it to do one. But what's actually happening here is I'm executing the ping command. I'm only pinging it once, and then the semicolon is what I added here. That just ends the current command, and on the same line I can execute another command, ls-al, which gives me some nice info. So where's the, yeah, right. Well, I guess there's nothing in this folder right now. That's probably why the other ls didn't work right here. Well, it worked, it just didn't return anything. This one is a little bit more verbose, and so you kind of get a little bit more detail about ls-al. But yeah, so it executed it. That's why we're getting this, because we were basically canceling out that ping command and adding our own command to the end of it. So was there remote command execution? Yes, there was. It was ls. And now let's try and get a shell. Is netcat on? So netcat's not on there. So the which command is a really nice command. It tells you what the path is for a certain binary. So if I do like PHP should be on there. Yeah, it'll return the path. So I did which nc for netcat, and it didn't return anything, which it means it's probably not in the path. We have PHP. Well, I'd be surprised if that's not there. Yeah. So there's bash, and this might come in handy. Yeah, okay, Python's there. So we're able to execute commands on the server. We don't have netcat, so I have to figure out a different way to do a shell, which shouldn't be a problem. Bash is there, so I'll probably just use that one. Get rid of that. And go to my reverse shells section. And you can see that bash is here, but I do have a lot of reverse shells for, and it's worth collecting them and putting them in your own playbook. Pentest Monkey, their cheat sheet is really, really good. It's still worth collecting them yourself. It'll organize it in a way that you'll understand. You won't always have to have certain internet access to get it, or if the website goes down and it's no longer available, you've got your resources with you. Every time you see a new reverse shell that you've never seen before, maybe it's, Pentest Monkey doesn't have everything, so put it in your little bag of tricks here. And so we are looking for bash, and that's this one right here. This is pretty common IP for my local network, so I don't even have to change this. 9999, I'll use that port. So we're going to create a reverse shell, which means that we need a listener, right? Because we are going to try and convince the target host to call us. So if we do get the target host to call us, we need to be listening for it. So netcat nvlp 9999. That's just the port. Netcat, don't do a DNS lookup, which actually is not that important here. Be verbose, enter listening mode on port 9999. You can use any port you want. I like 9999, 4444. There's kind of like these. They're not really conventions, but they just happen. I guess they are conventions. They happen all the time, or they occur lots. Quad 9s is just mine. And so this is on our Kali host. We're now sitting there waiting, listening, and I'm just going to copy this, and I'm going to execute bin bash in interactive mode. I'm going to pipe it through dev TCP, I'm calling my Kali box on port 9999, and I'm going to try and take the input and for that as well. So remember your semicolon, keep the semicolon, because that's going to kill the previous command. And all I did was paste in that bin bash command. And I am listening, right? I'm listening. Submit. It's hanging. That's a good sign. And we got ourselves a shell. So before I do anything else, I want to log that. Actually, I did a few things before I got here. There we go. So in Kali, I enter netcat nvlp quad 9s, and then in the browser on Kali, I entered this. Got a shell. Don't need any more of these. Usually it's not this quick. Usually you have to enter a lot more commands to get a shell, or you've at least tried a lot more things. This one was pretty straightforward. So all that to say, just this can get really, really long. So it still is worth separating out the shell and the kind of the first level, what you do inside and outside, and then. And yeah, in this case it was quite short. All we did was kind of do a simple authentication bypass using an SQL injection, and then remote code, or a remote command injection. I guess that should be... There we go. Save that. And now we've got a shell. So now we switch to the shell page. Up here, I've got a shell upgrade. I don't think I'm going to use it for this one. I tried this box a little bit before this recording, and it throws some wrenches into it. But I will show you why. Right now, we have a bash 3.0 shell. That's pretty old. And you'll know that if I'm hitting the arrow keys right now, we're getting that kind of weird, those weird commands. It would be really nice if if I hit the arrow key, it would go to your previous command, but because we don't have like a full shell on here, it's going to cause all sorts of problems. So I'm just going to have to deal with it, because in this particular box it's a little bit harder to upgrade the shell. So we're on the box. What do we do now? Well, I'm going to close down some things so it's a little bit easier for us to see. And just focus on here. Who am I? I'm going to hit the ID command. Well, looks like we are the Apache user. So this box was configured. We didn't get root out the gate, just like in Kioptrix 1 we did, right? We didn't actually get a reverse shell. We got we executed an exploit, and then the Apache server was running as root in Kioptrix 1. So we didn't even have to elevate privileges, but because this is an Apache user, and they are not root, they're not part of any special groups or anything, we're going to have to elevate our privileges to get root. So, where am I? var www html. That makes sense, right? We executed this command injection against a server, a PHP server, so it's gonna, like, that's the web root, so that makes sense. What's in there? We're seeing two files, index.php and pingit. Was that the... It's hard to tell. I think that's the second part of this, where we did our command injection. But there's two files in here. This included a login page, right? So it's got to contact something, like either they got creds hard-coded in or they're contacting a database. So let's take a look. So the cat command, where is it? Here it is. The cat command just dumps this file to the screen. And so what's nice about that is you don't need an editor or anything like that to do it. It's just kind of a nice quick and dirty way to look at files. And we're looking at this PHP file, and right out front we see that there's a MySQL connection to localhost John Hiroshima. Username, password. And that's for MySQL. So we found a MySQL username and password. Go to our discoveries. That could be useful. Is there anything else? Database, web app. Where I got that is it's selecting the database. So there's got to be like a web app database in there. And then this is where that SQL injection came in. And here's why. They are taking the username and password post parameters. They are not doing any sort of input sanitization. They are not doing anything special. They're not using stored procedures. What they are doing is they are just feeding them straight in, these variables, feeding them straight in here. So I'm going to show you why our injection worked here. I'm just going to put it into here, just so we can see what's going on. We entered single quote or A equals A, no ending single quote, right? That was our injection that we got the authentication bypass on. Here's what the query looks like normally, and it is substituting our text in here. So if we read this, it's going select everything from the table users where username equals opening, closing quote, or A equals A, so that's always going to be true. So this is always going to equal true. And password equals the same thing, opening, closing quote, or A equals A, which is always true. So both of these will evaluate to true, and it automatically bypasses it. So that's why our SQL injection works. How you would fix that is you guys shouldn't be writing code that does this. You should never be taking user-defined inputs and automatically feeding them into anything like a database or a command. And we'll try and find that command injection too, because there was two parts to this. There was the SQL injection, which caused the authentication bypass, and then there was the command injection, which it's called ping it. It's got to be where the ping command was done, but we'll look at it later. Use stored procedures. Use an actual framework that kind of does this under the hood, like maybe an ORM. There's a whole field called Taint Analysis, which looks at sources and sinks wherever the query is like executed, and it tries to work from both sides and meet in the middle somewhere. And if you can basically create a chain or a path from user-defined input into the execution of something, then you might have a potential method for attack. I'm going to leave that as an example for anyone who wants to, do some extra reading or something. But Taint Analysis, there's plenty of papers written about it. It's a really good way to do things. But yeah, it helps identify that static code analysis, or it could be dynamic, I think. But yeah, this is it's not as simple as like just it's all right here. It's quite obvious when it's there, but sometimes it's not obvious at all. These could be saved like hundreds of lines up in the code, and then the actual execution happens way later. So this is just good to know. But what is it actually doing? It's doing a query. It's getting the result. Okay, and then it's fetching. Okay, so it's executing the query, and then it's fetching a row. If the ID is blank, it is showing the login form. And if the row is 1, it is giving you the ping. And it's posting to ping it, and the input is IP. And then you're just submitting it. So if we look at the ping it file, it's taking that post parameter again, right? That's going to be user defined. It's printing it. And if it's submitted, it's going to take that IP parameter and it's going to just, hey, look, it's almost exactly like mine. It's going to shell exec ping. It's going to do that 3 times. It's going to ping whatever you give it 3 times. And it's concatenating, or it's appending, sorry, the target variable, which is just straight up our user-defined input, and it's just shell executing it. So that's why we were able to get a root shell, or a user shell, because PHP has a couple of methods to do this. Shell exec is one. There's system, I think there's shell, and there's also exec. So there's lots of ways to get this. So you should never really just be taking user-defined inputs and dumping them in something that is like, usually they try and ban stuff like this outright, like never used in your code, especially with PHP. But there are ways to do it in other languages too. So that's how we got our initial shell, is by exploiting that. Now that we have that, I didn't see another username and password, but John Hiroshima. It's MySQL, we might as well try it. Just double checking. We saw it in we saw MySQL in our scan. Oh, and here's our service scan, like scripts and services and operating system and stuff. Gives us a nice, just a nice overview. Yeah, it's a bit of an older version. Apache, that's older too. Kind of tripped up on this. Something's going on there. I'm not sure what that is. Cups is running, and then MySQL unauthorized. Yeah, kind of tripped up or something here. So yeah, MySQL is running. Let's try and connect to it. We have the user. Where is it? Here? Discover. John Hiroshima. Okay, so because our shell isn't a full shell, we're kind of getting some weird. We're getting some weird behavior. The exit command definitely. So this should have spawned in MySQL terminal, but it well probably did, but we're not able to see everything that's going on because we don't have a full shell. So there's an easy way around that. I'm just going to copy this. Okay, so the -e command for MySQL executes this SQL. So you don't even have to have the interpret command. You can just run it, and then it'll just dump the output to the screen in just standard out, which is what we have. So now we can see that there's a MySQL, test, and web app database. And we noticed from that script that that's the web app database we care about. So if I do -e, and I might actually just copy this because this is going to get tedious. All right. Use web app. All right, we're going to use that database. And then what are we going to do? We're going to show tables because we don't know what tables are in this database. Just one. Users table. So use web app, select everything from users. See what's there. And we've got ourselves 2 username and passwords. Those don't look like hashes, so I'm going to guess plain text, but maybe there's some weird crypto going on for this app, but I didn't see any actually in the, it would have been up here because it's just straight up polling. Where is it? It's just straight up polling username and password. It's not doing anything fancy. So these are probably plain text. So save that in our do that. And we got some more creds. This just helps provide some context for the creds. And my format of choice is the username : password. So we have we've got a few passwords here. We might as well try and use them. We have an SSH. Yeah, we have an old SSH connection. It was John and admin. So let's just try and SSH in as John the user. And yeah, okay. So this is pretty, for older boxes, you might come into this a lot, or run into this a lot. Basically, we're not finding any key exchange method. So my box is saying, hey, here are the methods that I support, and the target host is saying, well, here are the methods I support, and there aren't any matchups. So they are offering Diffie-Hellman and a bunch of others. Well, Diffie-Hellman, different types of Diffie-Hellman. So you can, this is common enough that I have just a blanket, just support all the things, especially with older boxes. So you go like this, chuck that in front. And what's actually happening here is the -o command is option. So SSH-o for adding an option, and the option I'm adding is a host key algorithm. Bunch of them, right? There's a Diffie-Hellman group. That's the key exchange algorithms, Diffie-Hellman group. And this is just a blanket. Like, I didn't need all of these to just support this, but I have like a blanket options list that I can add, and it usually solves this problem. It just supports a bunch of other ones. Diffie-Hellman is an older version and is now deprecated, so that's why this comes into use. If we go back up here to discoveries, Hiroshima. Whoop. Hiroshima. Alright, so that one didn't work. So let's try this one. Just pasted that in. And nothing. Okay. Admin, maybe that's the root. Let's try it instead of John. Let's try root. Maybe that's the trick here. I'm pasting in that admin password. Oh, okay, that didn't work. Alright, so these passwords didn't do a whole lot. Well, Hiroshima got us into MySQL, so that was useful. There's one more thing we can do with MySQL right now, and that's is to take a look at that MySQL database. Why that's important? I don't actually need all this. I need is because of this table right here, user. We can get more users if there are out of the MySQL table. Alright, so what we're seeing is that's gotta be a hash or something, some sort of encrypted password, because John's is Hiroshima, and we're getting this, and then the root says this, which is the same. So I bet you root's password is Hiroshima as well, and we can actually check that. We have to delete all this. Yeah, So the root MySQL password is also Hiroshima, although I doubt it helps, actually, because there's not a whole lot going on in that database. So we can add that to the list. And that didn't actually matter. All right, so let's take a step back and look at where we are. We know we are the Apache user. We got a few creds, got into MySQL. We were able to pull out some more creds for that custom web app. They don't really seem to help that much. I'll put the that in there. Yeah, that didn't seem to help us too much. So let's do some more enumeration. Let's take a look around and see what's there. We know who we are. We are Apache. Now let's take a look at the operating system. Uname -a. That's going to get us Kioptrix Level 2. Interesting. There's a different way to get more information. Proc version. Oh, I know why. There we go. This will give us, if you just cat the proc/version file, it'll give you a little bit more information than what you might get with uname-a. This is the one that I care about because that extra information can be useful. Let's take a look. Yeah, 2.6, Linux kernel version 2.6 is super old. I will just say outright, if you see 2.6, you're almost always thinking kernel exploit because 2.6 has so many kernel exploits. They've given us a version, so I'm actually going to put this here. Oops. Yeah, see, it's like last updated 2007. This is old. It's Red Hat, hence probably why I think I saw CentOS when we did our first. Oh, I don't even have it up. Where that would be in our scan. I thought I saw CentOS. Oh, it was in there. Yeah. So it guessed that it was running on CentOS. Which, Red Hat, close enough. Yeah. I'm going to bold that because I bet you that's going to be part of this equation. That's really old. There's just too many, unless they've patched the heck out of it to deal with that. I doubt it. But before we try those kernel exploits, let's look around a little bit more. Here, classic etc/password, right? Take a look at what's inside. This box is configured correctly. The X means that it is being stored, the passwords are being stored in the etc/password, or etc/shadow, which is how they should be. And if the permissions are correct, which they are, nobody but root should be able to see that. So that's where the passwords are stored. What this does do, though, tells us there's a valid root user, which there will always be pretty much a valid root user. But if we go all the way to the bottom, we're going to see two more. Like, we know there are MySQL ones there, but we get two more, John and Harold, right? We knew about John, but Harold, the user Harold. So we found two more users, no passwords, but they do have home directories and those home directories are locked down. Only Harold can see his, and only John can see his. Sometimes you can go into these, and sometimes actually you can do sometimes, even though the Harold directory may have permissions, maybe things like the SSH directory it's configured to be open, and you can guess, and if you can get in there and maybe even write a file or change, say, the authorized keys, I think it is, you can basically put your own key in there and SSH in as Harold. In this case, that's not the case. Can we do it for John? No. That's okay. That's a bit of a long shot. Sometimes that comes into play. But for level 2, maybe not. What else can we do? Take a look at the root directory, right? Let's just move there. Actually, we were in var/www/html before. There might be something in there, but it kind of look like default install stuff. Maybe in CGI bin. No, okay. So we're back into we're at root, the root directory, and you just kind of look and see if there's anything weird. Here's the root home directory. Permissions are set up so you can access them. Let's see what's in temp. So there's nothing in temp, and I'm just echoing the path to see where what my path looks like as the Apache user. It's pretty minimal, which I guess is why it probably didn't find a netcat or something, because if we go bin, is netcat even going to be here? No. There's a couple places it could be, but I just was curious. Alright. Well, I'm thinking that Kernel Exploit, and the reason I'm thinking that is that's a very old version. 2.6 is almost guaranteed to have something. It's just too old not to. So let's pull up search exploit. 2.6. Let's see what we got. I bet you there's a lot. Yeah. So obviously there's a lot, and using searchsploit, the tool searchsploit, is definitely worth it. Learning how to kind of drill down and craft your search parameters so that you get something useful. I'm sure at some point I'll make a video about that, because that is really important. Because if you got this many and you're under a time crunch, good luck. You're not going to try them all, because they're all in C. Not all, but you're going to have to compile these, and there's going to be weird flags for each. Like Kali is a Debian-based system, and I'm running 64-bit Kali, but we are trying to exploit. I'm pretty sure that was a. Go back to the shell. It's a 32-bit Red Hat architecture, so if I was to compile this on my Kali box, I'm going to have all sorts of flags to make that work. We can do it. It's just these are going to have to be custom crafted. Not custom crafted, but you're going to have to put some effort into it. So there's a bunch here. What is it? 2.6, it's like 2.69-55. So there's a couple of Red Hat ones in there. CentOS. Huh. Yeah, you can see that it didn't expand too much. I'm interested in this one. Oh, not this one, sorry. It's got the CentOS, the Red Hat. It's a little bit off, but I'm sure there's lots. Like, if you scroll down, I'm sure you'll see other ones. Let's take a look at this one. 9545. I'm sure I'm sure there's lots, right? That can probably fit the bill. Searchsploit -m will take that exploit and drop it in the current directory. So that's really nice for when you want to work with things locally. And there it goes. So now we've got that exploit local, the C file. So let's take a look at it. Socks end page, null pointer, dereference. The joys of C. Null pointers, buffer overflows, use after freeze. It is quite a range. It's good from 2.60 to 2.630. All those versions are vulnerable. And here's a nice list of everything that is. So I'm curious what we're pretty old on the Red Hat side. Yeah, we'll find out. It's even got some Ubuntu ones in there. Okay. Oh, is not vulnerable. Yeah, there's enough of overlap here. And here's a nice little help on compiling 464 and for i386, which I think this is. So just gcc wall, like, does just give me all the warnings, output to this name, and compile that. We don't have that name, we have the number, but that's okay. And we actually, how big is this file? It's not terrible. It's just good to review what's going on. Sometimes not all exploits are nice, and it's good to, as well as you can, review them and kind of understand a little bit about what's going on here, and just kind of do a sanity check. Looks like it's trying to put some stuff in temp and some error handling, some opcode, and in general fashion, what these will try and do is try and escalate privileges in some certain way, and then call a shell. In this case, it's bin /sh interactive. All right. So what I'm going to do is I'm going to try and get this file over to the target host, because I can compile it locally with all the flags and stuff, but am I in temp already? Well, I am now. Okay. What I need to do is host this file on my Kali box and then pull it down on the target host. So how do you host it? Sudo python 3, use the module http.server, hosted on port 80. Basic HTTP server. So now it's hosting this directory on port 80. Great thing about port 80 is wget. Port 80 is HTTP, remember? That's my Kali host. The file. Oops. And HTTP OK is 200 OK. Looks like the request came through, so I can Control C, kill that server now. It's hosted and it's transferred over. And we've got it here. GCC, that file, output to that. We got a warning. Warnings are okay. No new line at the end, that's fine. You can see that it created this executable, this binary. That's what we want to see. Now we are going to execute it. And some stuff happened. It looks like we have an SH, ID, and we've got root. Okay. So the kernel exploit worked. In this case, it spawned SH, so we are in bash, so it's a lot easier to figure out what's going on. Sometimes it'll spawn a bin bash, and you'll just get another bash shell, and it's not exactly clear that you elevated privileges. Always run that ID command, figure out who you are. You can see that actually the Apache group is still that, so they probably did like a set UID and a set GID as 0 and 0, which would automatically make these as root. But great. We are now root, so let's go check out the root directory because we couldn't get in there before, and here we go. We were able to get in here. You can see there's a MySQL history, install logs, stuff like that. I'm curious. So where is the top of this? Oh, so many. Okay. This is where like a nice bash with color is nice because then we'd be able to see. But what I did was I catted the MySQL history file, because if this was just one step in a multi-tier network per se, or if you're trying to laterally transfer, what you'd want to do next is kind of look for creds, look for something else, right? So dump the history files. There's bash history, there's in this case there's MySQL history and things like that. There could be logs, but you can see that, hey, what's going on? Here they are creating the web app. They're using it. Insert into values admin hello. Interesting. The password's hello. That's weird. Oh, why would it do that? I'm not sure. It looked like it was. It looked like it was plain text. Not sure why it's like that, but let's see. Select where user's John. Okay, looks like they're trying to figure out what's going on. Here's all those passwords. John, web app, password. Okay, they actually started using that. And flush the privileges. Grant that user all sorts of permissions. And then now they're setting password for admin. Oh, and here we go. Here we go. They've actually set that password. That's why it wasn't. Yeah. So they're messing around with passwords here. So that's Kioptrix Level 2. We found a web app. We were able to dump some of its creds. We got the root users of MySQL and John, MySQL users and their passwords. We found the web app users and their passwords. We were able to gain root using a kernel privilege escalation, and we were able to gain initial access by first using a MySQL injection authentication bypass, and then a remote code injection command on a web app page that just took a command, didn't sanitize it, and then just chucked it in the ping command, which we were able to take advantage of. Well, guys, If you enjoyed that, grind some beans, boil some water, click subscribe. Thanks.